In 2022, when Ukraine began receiving Western infantry fighting vehicles, the vehicles that attracted the most attention were the American Bradley and the German Marder. Both were well known, both had combat records, both had the political weight of major NATO allies behind them. Quietly, without the press releases and parliamentary debates that accompanied the Bradley and Marder deliveries, Sweden also sent infantry fighting vehicles to Ukraine, the CV-90P. By the end of 2023, Ukraine had received more than 60 of them. Ukrainian crews, who had operated Soviet-era BMP vehicles their entire careers, reported that the CV-90 was different from anything they had experienced. Not just better armed, not just better protected, fundamentally different in how it allowed them to fight. Within months of deployment, CV-90-equipped Ukrainian units were reporting engagement results that their commanders had not anticipated. The vehicle was doing things that infantry fighting vehicle doctrine said required either a heavier platform or a more sophisticated one. It was doing them in the mud and cold of eastern Ukraine, in conditions that had destroyed lesser vehicles. Sweden had built it for exactly those conditions. To understand why the CV-90 exists, you need to understand Sweden's specific military problem in 1984. Sweden was officially neutral. It had been neutral since the Napoleonic Wars. But Swedish neutrality was not naivety. Swedish military planners knew precisely what a Soviet invasion would look like. Soviet armored columns crossing the Baltic, landing on Swedish coasts, driving through the Swedish forest terrain towards Stockholm. The Swedish terrain was the key variable. Narrow roads through dense birch and pine forest, frozen lakes in winter, soft ground in spring thaw, river crossings without adequate bridge infrastructure. The terrain that would slow a Soviet invasion would equally slow any vehicle Sweden used to stop it. Sweden needed an infantry fighting vehicle that could operate in Swedish terrain as effectively as Soviet vehicles operated in their own training grounds. The American M2 Bradley was too heavy for Swedish forest roads and bridges. The German Marder, though capable, had been designed for the Central European plain. Neither vehicle had been optimized for the specific combination of deep snow, frozen lakes, narrow forest tracks, and soft spring mud that defined Swedish operational terrain. Sweden decided to build its own. The program that produced the CV-90 began in 1984 as a joint development between the Swedish military and Hägglunds, a Swedish vehicle manufacturer based in Örnsköldsvik on the Bothnian coast. Hägglunds had been building tracked vehicles for the Swedish military since the 1960s. Their engineers understood Swedish terrain because they operated in it. The design brief was specific. The vehicle had to operate in -40-degree temperatures without preheating. It had to cross Swedish lake ice without breaking through. It had to navigate forest tracks that would swallow heavier vehicles in spring mud. It had to carry 8 infantry, fight from the vehicle, and survive the weapons that Soviet infantry fighting vehicles mounted. The CV-90 that emerged from this process in 1993 was not the heaviest infantry fighting vehicle in NATO. At approximately 23 tons in its initial configuration, it was lighter than the Bradley and comparable to the Marder. What distinguished it was not its weight class, but its combination of firepower, mobility, and ergonomics. The main armament was a 40mm Bow autocannon, the most powerful weapon mounted on any production infantry fighting vehicle at the time of its introduction. The 40mm round was significantly more lethal against light armor than the 25mm rounds fired by the Bradley or the 20mm rounds of the Marder. At 2,000 meters, the 40mm APF-SDS round could penetrate the side armor of a BMP-2 infantry fighting vehicle, kill a BTR-80 armored personnel carrier with a single burst, and suppress infantry in prepared positions more effectively than any rival. The gun fired at 300 rounds per minute. The turret was fully stabilized. The gunner could engage moving targets at 2,000 meters while the CV-90 itself moved at full speed across rough terrain. Swedish engineers had learned from the Israeli Merkava experience, from the South African wheeled vehicle research, from every post-1973 analysis of what infantry fighting vehicles needed to do in actual combat rather than on test ranges. The stabilization system was not an add-on. It was designed into the vehicle from the beginning. The CV-90 suspension was a torsion bar system with 7 road wheels designed specifically for high-speed movement across the soft and irregular terrain of Scandinavia. On hard ground, it could reach 70 kilometers per hour. On snow, it maintained traction that heavier vehicles lost. On frozen lake ice, its ground pressure was calculated to remain within safe parameters for the ice thicknesses typical in Swedish winters. The troop compartment carried 8 soldiers in seats designed for the ergonomics of fully equipped infantry in Arctic clothing. The heating system was independent of the main engine and capable of maintaining interior temperatures at -40-degree external conditions. The vehicle could cold start at -40 without preheating, a requirement written into the specification after Swedish engineers documented what happened to vehicle reliability in Nordic winter conditions. The export success of the CV90 was not immediate. Sweden ordered 509 vehicles in the initial contracts. The first export customer was Norway, which evaluated the CV90 against the American Bradley and German Marder in 1994 and selected the CV90 on the basis of its performance in Norwegian winter conditions. Finland followed with an order for 102 vehicles. Switzerland ordered 186. The Netherlands ordered 184. Denmark ordered 45. Estonia ordered 44 for use by units, now committed to NATO's eastern flank. And then, as the CV90's export record accumulated, something interesting happened. Military analysts began comparing the CV90's performance data against that of its American and German competitors. The 40mm Bofors cannon consistently outperformed the Bradley's 25mm in penetration and lethality at range. The CV90's electronics, updated through successive variants, matched or exceeded the Bradley's fire control in comparable tests. The vehicle's Arctic performance was in a different category from any American or German rival. 8 nations operating it reported higher availability rates than the vehicles it had replaced. By 2022, more than 1,200 CV90s had been built across all variants. 8 nations operated the vehicle, not because Swedish marketing was effective, because the vehicle performed better than its competitors in the conditions where those nations expected to fight. When Sweden decided to send CV90s to Ukraine in 2023, the vehicle was already proven in Arctic conditions by Norway and Finland. Ukrainian winter conditions, while not identical to Norwegian Arctic winters, shared enough characteristics that the CV90's cold weather engineering translated directly. Ukrainian crews trained on the CV90 in Sweden and Poland reported that the vehicle's systems remained operational in temperatures where other NATO equipment required additional maintenance. The 40mm cannon proved devastating against Russian infantry carriers. A BMP-2 struck by a 40mm APF SDS burst at 1,500 meters did not survive. A BTR-82A struck at 800 meters was destroyed with a short burst. Russian infantry dismounted from carriers to avoid vehicles they knew were carrying 40mm guns with 2,000-meter effective range. The psychological effect was immediate and measurable. Ukrainian commanders reported that Russian forces changed their tactics in sectors where CV90s were known to be operating, avoiding the open approaches that the 40mm gun dominated. The CV90's armor protection, in its upgraded variants, reached Stanig 4569, level 5 on the frontal arc, meaning it could resist 25mm autocannon rounds from the front. Russian 30mm autocannon rounds from a BMP-3 or BTR-82A could not penetrate the front of a CV90 at combat ranges. The vehicle's combination of superior firepower and superior protection against its most likely opponents created an asymmetry that Ukrainian crews exploited systematically. In engagements documented by Ukrainian units, CV90s consistently engaged Russian infantry carriers at ranges where Russian return fire could not penetrate CV90 armor. That asymmetry was what Swedish engineers had designed 40 years earlier when they decided that the vehicle-fighting Soviet infantry carriers needed to be able to kill them before they could effectively return fire. Sweden had been neutral for 2 centuries, but Swedish neutrality had never been passive. It had been armed, prepared, and engineered for the specific geography and specific threat of the Baltic region. The CV90 was the expression of that engineering in steel and electronics and Bofors cannon rounds. When Sweden joined NATO in March 2024, it brought with it not only the CV90, but the design philosophy that had produced it. The philosophy that the vehicle a nation fields should be optimized for the terrain where that nation fights, not copied from a design optimized for someone else's geography. 8 nations had already reached the same conclusion independently by purchasing the CV90. The Ukrainian experience confirmed it in combat. The quiet Swedish vehicle that nobody had expected to dominate the infantry fighting vehicle market had done exactly that, not through marketing, not through political deals, through engineering that worked when it mattered in the forests and frozen fields and muddy roads where infantry fighting vehicles actually fight.